Thanks, everyone. Yeah, excited to chat a bit about some of the work I was doing at CISA and some of what I'm up to now with Corridor. Looks like the conference might be starting to fan out a bit, so feel free to come up towards the front if you want to. Let's dive into it. So I'm Jack. I'm currently the CEO and co-founder of Corridor. Come from background in security research and computer science. Got into security through bug bounty programs. And this started when I was in high school. I stumbled across a vulnerability in a cryptocurrency website where I noticed I could send a negative amount of money to other people on the site. So through the course of that, was able to steal money from people's accounts. Fortunately, they had a bug bounty program, so I was able to report to them, got paid, and then started teaching myself more about security. Eventually got into the top 100 rank of bug bounty hunters of all time on HackerOne. Studied computer science at Stanford, and then most recently was working in government at CISA, Cybersecurity and Infrastructure Security Agency, and was really leading on the Secure by Design initiative, doing a bunch of work to encourage tech companies to prioritize their product security. And I'll be focusing both on the work then at CISA, as well as how I've been applying Secure by Design through my new company, Corridor, which I started back in January when I left CISA, and really we're focused on securing AI coding. So really want to kind of walk through this journey of working in government to advance the state of software security, and now from the other side here, so can get into that. To start, let's kind of motivate some of the angles behind Secure by Design, right? So where we are today, we still have these same basic preventable security weaknesses that are causing the same vulnerabilities again and again. So if you look at the, for instance, here we have the OWASP top 10 in 2017 compared to 2021, and not much has changed. If you look, there's MITRE, for instance, published this paper on unforgivable vulnerabilities in 2007. Spoiler alert, it looks basically the same as this, right? So we're going on several decades of the most prevalent types of vulnerabilities being pretty much exactly the same. Right, if you look at, and I'll dive into a few case studies, right, but memory safety issues were first documented in the 90s. We were going on 3 decades of having buffer overflows, and they're still one of the most commonly exploited vulnerabilities out there. Likewise, SQL injections. Fun fact, MySQL introduced parameterized queries in 2004, which can prevent SQL injections at scale. And yet here we are, several decades later, still dealing with, vulnerabilities like this. The MoveIt hack, which compromised, right, this file sharing software that led to hundreds of individual breaches across universities, others. That was a SQL injection, which we've known how to prevent for over 20 years, and it's still making headlines. So really, right, we're in this pattern where these basic vulnerabilities are being exploited to cause significant harm. If you look at some of the exploitation of network edge devices, right, it's the same types of vulnerabilities in a very focused set of products, right? These corporate VPNs, those sorts of devices are appealing targets to attackers because they're right at the boundary of the internet and everything sensitive a company has. So naturally, right, we've been seeing state-sponsored cyber attackers going after them. This is part of, right, the Volt Typhoon, Salt Typhoon campaign you might have heard about. And if you really trace it back to the origin, right, most often it's either a preventable software vulnerability or an insecure default configuration, right, something that the vendor could have done more to prevent the vulnerability in the first place. Okay, so we have this problem, right? It seems like, some basic practices at the vendor level might be possible to make this better. So how do we actually get that adopted in practice? So I'll talk about the work I was doing at CISA through the Secure by Design initiative, and then get into what I'm doing now at Corridor. For some background on Secure by Design, right? So we launched this initiative at CISA in 2023. the focus was really to pinpoint, this was in line with the White House's national cyber strategy at the time, to shift the burden of responsibility for cybersecurity away from those least capable end users and onto those who are most able to address it, namely the software vendors. So we published a bunch of guidance with, I believe it was 13 other countries that you can see here across 3 different continents, and really got significant adoption both on the side of other cybersecurity authorities as well as from companies. So there's over 300 signers of the Secure by Design pledge. This is something I put together to get companies to commit to basic product security improvements. And there's 7 items associated with the pledge to do things like increasing the use of multi-factor authentication across their products, to reduce the rate of default passwords, reduce entire classes of vulnerabilities. All these areas, right, that seem relatively basic, but you might be surprised by even then the amount of work that's required to get commitments from companies to even these pretty basic items. But the good news, I would say, is that real progress is being made here, right? So there's a lot of work around consensus building, and it's not easy to get one, let alone 300 companies to agree to do something the government says. So we spent a lot of time in figuring out what would be both sufficiently actionable, something that's achievable by them, while also raising the bar and continuing to do so, right? So the goal of the pledge was for companies within 1 year of signing it to document the progress they've made. And the pledge came out in 2024, May of 2024. It's been over a year, so some progress has come out. But it's not without the critics. I pulled a few fun tweets about it. Someone said that the pledge itself is substantially meaningless, and utter nonsense. Jack Cable has to know better. Maybe I do. But really want to dive into, right, what actually happened as a result of this, right? How effective are some of the levers that we have in government? How does that compare to what you can do within private sector? And want to dive a bit more into what I was talking about, right, with the fact that really at the end of the day, for all the talk about 0 days, for all the talk about, these very sophisticated attackers doing very sophisticated attacks that there's nothing we possibly could have done to prevent, and yet, right, so this is here from MITRE, their known exploit vulnerabilities, top root causes, so essentially the classes of vulnerability that led to the most exploitation in the wild. And you'll see, right, top 3 there are memory safety errors, use after free, buffer overflow, out of bounds write. These are all things, again, we've known about for decades and now have many great memory safe programming languages that prevent these from happening outright. And yet these are still the most commonly exploited vulnerability. So let's dive into 2. So start with memory safety, right? And here I have an interesting graph that comes from Google and is looking at the prevalence of vulnerabilities in Android operating system. And what they noticed is as they started on the left, right, lowering the amount of code that they wrote in memory unsafe languages, I believe that they switched to Kotlin for writing parts of the OS, you'll see that the number of memory safety vulnerabilities dropped quite significantly. And what's interesting is that this isn't like on the left, right, that's the rate of new code. On the right, that's the rate of memory safety vulnerabilities as a whole. So what they observed was that since the vulnerabilities that would be exploited discovered were most often in new code, even with all of their legacy code still there, by changing their new development practices, they were able to reduce the rate of memory safety vulnerabilities by about 50%. So that's pretty impressive, right? And it's not just Google. We've seen, Microsoft is rewriting parts of the Windows kernel in Rust. Same thing happening with the Linux kernel. Amazon's done a bunch here. So there's a lot of good progress being made, but still obviously a lot of room to go, right? And especially when we get into the legacy problem where companies can have millions, billions of lines of code written in memory unsafe languages, it's something where that will take time to address. But certainly, for instance, if you're a company building a new product today, I think the argument is very clear, right? You should not use a memory unsafe language. Don't use C or C++ if there's one thing you take away from this. Um, Likewise, right, I mentioned SQL injection vulnerabilities, where these are, again, a type of vulnerability we've not just known about for decades, but we've known how to prevent at scale for decades. And yet, software companies are still introducing the same type of bug over and over again. But that's not to say it's impossible to prevent, right? Many companies, Google, for instance, has talked about how they've done this at the type level to make it impossible for developers to introduce a SQL injection vulnerability, right? Because if you want to construct a database query, it literally won't let you include user input as part of the query string itself. So it's not that this is, some deep technical problem where we have no idea how to prevent it. There are technical challenges to it. But the bigger aspect, right, is that this is one of business incentives, where the majority of businesses out there today lack the incentives to produce more secure code, right? Perfectly secure code is something that we can't achieve, but certainly code can be much more secure than it is today. Okay, so getting into some of the action as a result of the pledge, we saw some good things. For instance, we saw each of the major cloud providers, Google, Amazon, Microsoft, move towards requiring MFA for their users. I've gotten some emails around that. We saw action from a number of other companies as well. Some have published a bunch of good statistics on things like patch uptake numbers, the rate of various vulnerabilities in their code. But I think it's also important to look at what we're not seeing, right? Where, and now that I'm outside of government, I can speak with a little more flexibility, where over 300 companies have taken the pledge. As of today, if you go on CISA's website, there's a list of companies who've put out progress reports. I counted a few weeks ago, 40 or so have put out progress reports, right? So there's around 250 or so companies who haven't yet said anything despite taking the pledge and saying we're going to put out progress reports as a result of this. So in some ways, I don't know if this is a bad thing, right? Because it allows the companies who are actually doing a good job to distinguish themselves, to say, hey, we actually followed through on our commitment here, right? But I think it is a signal that, voluntary action from companies alone isn't enough, and does get into something deeper, right, with the market forces where all too often today, companies just aren't incentivized to produce more secure software. So that's kind of the takeaways from the government side, right? And can dive more into other elements around, liability and really where I think this needs to go. But want to step into a bit now from my current perspective, right? And in particular, gonna point to, right, one of the biggest changes that when I was at CISA was only starting to bubble up, but now it is, pervasive. And that's around AI coding, right? If there's one use case of AI that has actually materialized, it's around software development. The fact that, it's hard to deny that an engineer now with AI coding tools can do so much more than they were able to do ever before, right? There's some statistics out there from Stack Overflow. 84% of developers are now using AI coding tools. 30 to 4 companies encourage the use of AI coding assistants among their employees. That's from GitHub. That number seems pretty low to me, right? And I expect that there is some bit of a lag between companies who are fully making use of this and where this needs to be. But I think if you've spent any amount of time using these tools, it's very clear that that we're not going back when it comes to software development, right? That AI enables us to move so much faster than ever before, which is really exciting, right? For so many reasons. It's going to enable so much more innovation. We're at the entrepreneur track. I'm sure it's going to be a lot easier to build a new product than it has been before. But you also have to think about this from a security perspective, right? Where we know that AI is introducing these same types of bugs that human developers have been introducing for decades, right? There's no shortage of examples of a coding agent that introduces SQL injection or hard codes your credential or deletes your production database, all these things that are maybe some unintended side effects of all of the value we're getting out of these tools. And they're not just one-off examples, right? There's benchmarks out there. Backbench is one, looking at how well LLMs do at generating secure code. And the answer is that even the best models, right, GPT-5 is on top there, introduce vulnerabilities about anywhere from 20 to 40% of the time. And there's a lot of work that needs to be done in building better benchmarks here, work from the model providers from OpenAI, Anthropic, in order to actually assess their models against these benchmarks, see how well they're doing, and see how they can improve. But the reality is right now, right, and I'd say really breaking down into two main types of vulnerabilities. There's the more basic flaws, right, SQL injections, memory safety, things that I would hope a year or two from now the models are quite good at not introducing. But then there's also the more contextual ones, the authorization flaws, the other sorts of business logic errors that aren't going to, in my opinion, be addressed at the model level. And I'd say that's really where I think there's a lot of opportunity, right? If AI coding is the future, if it's the way that every company is going to be building their products, then we need to make sure that AI coding is not just, helps you build a quick demo, but can actually build enterprise-ready code. And a core part of that is around security. So that is what led us, right, to start Corridor, with this premise of making sure that AI is able to write software that is more secure by design. And to me, it's a really exciting opportunity, right, because and one of the things I've advocated for a while is for security to be, introduced into the education process for computer science students, right? Right now, none of the top 20 universities in computer science have any security course required in order to graduate, right? And there's a lot that needs to be done to make sure the developers know more about security. Right, I think there's the promise in parallel of AI, where on one hand, as we've seen, right, it's introducing a lot of vulnerabilities. On the other hand, for the first time, we don't need to, right, the developer doesn't have to be that final layer to make sure that this code is free of certain types of vulnerabilities. If the coding tools can get better, then we have a better chance of preventing some of these vulnerabilities at the source, right? Maybe I don't have to be here in 10 years talking about how we've been dealing with SQL injection for 4 decades now, because hopefully we'll have, made that something of the past. So that's what led my co-founder and I to Ashwin to start Corridor. Started this back in January when I left government, really with this focus on securing AI coding. And it's been a great journey since then. I'd say, right, where we went from was us working out of our living room. Now we have 8 employees, and we're doing a public launch of the product actually next Thursday. So definitely would welcome any product feedback. But I'd say, in doing this, and as you can imagine, quite different from working in government, and yet in some ways I think there are some similarities where, and actually Ashwin and I had worked in government together before in 2020. We were at CISA building out tooling to help election officials understand where their vulnerabilities were ahead of the 2020 election. And I think I'd say really the biggest qualities that made me excel both in government but now in private sector, I think persistence is the biggest one, right? Where you're going to get all sorts of things thrown at you. You're going to have to move extremely quickly and adapt based on that. So I'd say really thinking about, takeaways, lessons learned. I think one is just the speed of execution, especially now with AI coding, right? The amount of technical effort it needs to build a product is significantly lower, which means that it really, is up to you in order to get out there, get in front of customers, and build something that's providing value, and likewise be able to, adjust and learn quickly based on that. The other thing I think is, there's been no better time than now to start a company where, especially, right, there's VCs are throwing all sorts of money at this, but also, like, you don't need a ton of money to, build a functional product now. You can, take some of these AI coding tools and do a pretty good job at building even just a POC or turning that into a more functional app. So I'd say there's been happy to talk more after the talk as well. But just so many great opportunities, right? And especially in the security space, right, where we are at no danger of this industry going away. I think that the problems are only going to be magnified, and even, for all of the talk of, AI putting security professionals out of work and all those sorts of things, I think we're a long way off from, truly getting to the root cause of a lot of these issues. So I think, that's, well, maybe not great for society, and there's a lot of vulnerabilities that might get introduced. It does mean that there's never been a better time to get into security than now, in my opinion. So I know we have just about 5 minutes left, which I want to leave for questions. So with that, thank you, everyone, and happy to take your questions. Yeah. So I think that's certainly a possibility, right? The hope would be that we can make sure that, AI is writing code that's not just secure by design, but, high quality as well, right? I think the state of the AI coding tools today is that they, do introduce, bloat and technical debt, where, right, if you spend time with, some of these coding agents, you ask it to fix something, it tries something, doesn't work, tries something again, and like the code just starts to pile up. So I do think that is a real possibility, right? And I think that's where, in some ways, right, we're at a crossroad now where it's a lot easier to write secure code from the start than it is to take, legacy existing piece of software and augment with security. In some ways, you're better off rewriting things. So I think from that perspective, yeah, the time to start is now, and that's really where I hope we're going. Yeah.
Just to follow up on that, have you seen any evidence that the AI LLMs are any good at taking, let's say, some legacy C or C++ code and replacing it in Rust?
Yeah. Yeah. So they are, and this is something that there's actually a DARPA initiative called Tractor, great acronym translating all C to Rust, that's focused on this, is funding, research into this. They'll put out open source tools as part of that. So I think there's a ton of promise there, right? And kind of a lot of what we're focusing on with Corridor is focused on new code going forward. But yeah, I think there's tons of opportunities, right? And because if we want to get to a better place, we have to both be looking at the new code, but also getting to a better place when it comes to legacy code. And yeah, it turns out that's something that, if you combine AI with some more deterministic methods, can get pretty good results. Yeah.
You mentioned that when you were working at CISA, all the vendors that signed on, only 40 of them actually, followed through on their own. How powerful a lever do you think the education component is, where you were trying to influence people getting, not people getting cybersecurity degrees, but getting computer science degrees if they were required to take basic cybersecurity, but if they weren't trying to be secure by design, say they've done more from the get-go, and how easy is that to do it?
Yeah. So I'd say there's a couple levels here, right? There's both the individual developer level, where certainly I think we, need to do a lot to make sure that developers actually know a thing or two about security, right? And while improvements at the AI level can help, I think, ultimately my mental model of a lot of these AI tools is, right, they're best used when in the hands of someone who knows what they're doing, both from, a general software perspective as well as security. So I'd say that's certainly one element where, yes, we need to make sure developers are more knowledgeable, and, I think every school should be making security a fundamental part of kind of how they're teaching future software engineers. But then there's also the, more corporate incentives where both are necessary, right? If you have a company who's solely prioritizing speed to market over any semblance of security, then that's not going to have positive results. And, there's been discussion around, should we have a form of software liability where software companies can actually be legally liable for security vulnerabilities in their code that lead to harm? I think that the answer is yes, and there's probably a long way to get there, but, it's not unprecedented where every other industry does have a form of liability, right? If you buy a toaster and it explodes, then that's on the vendor, and you can sue them. But right, if a software product has a vulnerability that enables a cyber attack, then right, their warranty means that there's pretty much nothing you can do. So I think that's the other direction, getting more serious around that. Cool. Time for maybe one more question, anyone? Yeah.
Nobody else. Following up on your liability point, do you think like the underwriters labs for electrical products is a model, to do that for for verifying the code and secure by design?
So yeah, I think there's an element there, right? One of the other reasons why, right, we have market failure in many ways around security is that there's a lack of information when you're going to buy a product about the security measures in place, right? Companies can say we have like military grade encryption and all these sorts of things, but in practice, when it comes to, are they preventing entire classes of vulnerabilities? That's not something you can readily see. You can look at, proxies, how many CVEs do they have, things like that. Which is also challenging since we want to encourage, the publishing of CVEs. But I'd say ultimately, yes, more transparency here will help quite a bit. There's a good letter, if you haven't seen it, from Pat Opet, the CISA at JP Morgan Chase, that goes into really what they want from their software vendors. So I think, the more that companies who are buying software can articulate these demands, the better. And with that, I believe we're out of time. So thank you, everyone.